back and very excited to be here. It's lovely outside. It's Saturday afternoon. So thanks and the fact that you're sitting here to hear about all these talks says something about your level of interest and motivation to learn more about the field. Today, I'm going to be talking about one way to think about social learning and how that extends to learning about ourselves and about others. But first, let's think about what learning looks like. Raise your hand if you have seen this video. Any hand up? Some of you. Raise your hand if you haven't. All right, so enjoy the video because it's quite entertaining. This is just a video of a baby who crawls around the room for hours, just having fun exploring all the objects in the room. And it's often used as a remarkable example of a curious human learner who actively explores the world and generates new data and learns how the world works. However, what is not captured in this field of view are his caregivers and his family members who are probably just nearby, who created this safe environment for the baby with lots and lots of objects. And if the baby were ever to put himself in danger, they would come right over, stop him, and try to tell him not to do it again. So learning does not occur in isolation. Humans as a species have evolved with others and to be with others. And the kinds of evolutionary pressures like competing with others and cooperating with others and making connections with others in newer ways have shaped our brains and shaped our minds. And as individuals, we're surrounded by other people from the moment we're born, and we observe them, we interact with them, we bond with them. And as humans, we have created all kinds of cultural institutions to promote learning from others, from the way we raise our children to even how we live our lives in college and conferences. And actually, we're sitting in one of those contexts right now, where the whole point is to try to learn from others and share what we know. So there's no doubt about the fact that we learn a lot from other people. It's very important for who we are. However, we still know very little about what makes human social learning so distinctive, powerful, and smart. Because even though many other non-human species do learn from others, it looks very different from the ways in which humans do it. So that's the primary question that has been guiding my lab's research. So our story of learning and how we learn from others basically starts from how we learn more broadly. So in the last few decades, developmental psychologists have characterized learning as theory building. And there has been Bayesian models of human cognition that have formalized these processes as probabilistic inferences over abstract structured representations. And the idea is that humans have rich priors about the world that support powerful inferences. And the evidence or the data for that kind of learning often comes from our own experiences. For instance, if you see a child over here, just like the baby that you just saw in the video, the baby might interact with this toy and then do something and something happens and you might learn from that kind of data. So which can be formalized as observing data to update your prior beliefs. Yet, and consistent with this, even in prior studies have found that even infants can engage in exploratory play, test hypotheses, and learn from this kind of evidence. Yet, just like what you have learned from watching the video, there is something missing in this picture, which is other people who may be around the learner, interact with all these things, and sometimes the learner, instead of doing something with the toy themselves, the learner might be seeing other people interacting with this object. So the idea behind the inferential social learning described by a recent paper is that learners not only learn from self-generated data, but also learn from information provided by others. And the question is, how? If you think about it, any observed data has history, how it came to be. But it matters especially when that data comes from other people. Because people do things and generate data in many, many different ways. So imagine a person who comes into the room and does something with this toy. It can be many reasons for why that person did so. It can be incidental, meaning that the person didn't have any regard for the learner and actually did something accidentally. And if the person does something and the toy makes an effect, then the learner may be able to learn from just observing that kind of data. But that's not the only case. Sometimes the person might have an instrumental goal that is not doing anything related to the learner, but maybe this person just wanted to play with the toy or make something happen with the toy. And that's data too. And sometimes the person may actually have an instructional or communicative goal to try to show something to the learner with a particular purpose of perhaps making the learner learn how the toy works. And the idea is that by considering how the data came to be, who generated the data, how was it generated, why did the person did this, to the extent that the learner can consider these kinds of things and think about why, whom, and how, the learner may be able to draw different inferences even from seemingly the same kind of data. And these kinds of inferences can be especially powerful when you're learning from actually people who are doing this for the benefit of the learner. And what this means is both the learner and the other person who's showing the data, for instance, a teacher or a caregiver, are both using some aspects of mental state reasoning, as well as what I'll talk about briefly, naive utility calculus. I'll try to explain this in a little bit later, but the main idea is that both parties are thinking about the minds of each other. So this picture is what I call the picture of inferential social learning, where the learner's interpreting the data to try to figure out what the teacher is trying to convey and update beliefs accordingly. And at the same time, the data comes from a benevolent informant who's generating the data to convey what is maximally helpful for the learner to know. And in this kind of context, the information that's being exchanged in this kind of context take on interesting properties. The learner expects and the teacher conforms to that expectation of the data being true of the world and sufficient enough for the learner to understand the true hypothesis and not superfluous, meaning that unnecessary or unuseful data may not necessarily be transmitted in this kind of context. So there's three key hypotheses that comes from this kind of picture. First, learners should be drawing different inferences depending on how others generate data. And second, the learners may be able to evaluate others based on the quality of the data. And third, if the learner understands how data can be different depending on the person and evaluate other people too, the learners may be able to also act as teachers themselves who are generating helpful data for other people. So what I'll try to do in this talk is try to go over just very briefly some of the past work we have done in order to provide evidence for these three hypotheses and try to give you a sense of how this picture extends to learning about the self by showing you some of the ongoing work in the lab. First, what does it mean that the learner can draw different inferences depending on how others generate data? Well, imagine this kind of box here. And as you can see, there's many toys that are blue and yellow, but most of them are yellow, just a few of them are blue. Suppose I am selecting 3 blue toys from this box and show you that all these blue toys, if you squeeze them, they make a funny sound. Now, from that kind of action, you can certainly learn, oh, blue toys make these funny sounds, and you learn something of the blue toys. However, even if I didn't tell you anything about the yellow toys here, from the fact that I went out of the way to select just the blue ones out of this kind of box says something about the yellow toy. maybe I did this because the yellow ones are not that, don't have that property. So what we have shown is that even infants can distinguish sampling processes. That is this person trying to select data randomly or with a particular purpose deliberately? And they can use this information to draw inferences about objects that haven't been demonstrated yet, like the yellow toy over here. And if you think about what it means for the person to select data, when we learn from someone who's knowledgeable and trying to teach you, that's specifically an instance where the person is trying to select the most useful data for the learner. So when young children are learning from a person who claims, I know all about this toy, and let me show you how it works, and the toy looks kind of complicated and it may have multiple functions, but if that person demonstrates only one function of this toy, so you press this button over there and the toy lights up, then the children not only learn about that function, but even if I don't tell them anything about the toy, they reason that, oh, and it actually doesn't have any other functions. That is, they can go beyond the observed data to draw inferences about the world, precisely because they understand that this person selected the data and the fact that I'm knowledgeable about the toy. Now, this is a case where if you didn't know anything about the toy and I presented myself as a helpful teacher, you would make this kind of inference by going beyond the data. However, suppose I showed you one function of this another rather complicated looking toy, but you actually knew that there are other functions that actually are interesting. In that case, you can actually evaluate the quality of evidence that I provided to you based on what you already know about the world. Well, maybe this person is not that helpful. This person was actually underinformative, which suggests that I wasn't able to really generate the data to convey what's most helpful to you. So this is a case where children can evaluate other people based on the quality of the evidence they provide. And what we have shown is that children can judge or evaluate a teacher who shows only 1 out of 4 functions of a toy, compared to a teacher who shows the same thing, but the toy doesn't have any additional functions. And this is interesting because in principle, the teacher didn't do anything inaccurate. The person didn't do anything glaringly wrong. The function was still true of the toy. However, because of the presence of additional functions that were not demonstrated, children were still thinking that this person isn't as helpful. However, interestingly, children can also pardon this kind of omission when the teacher wanted to show but couldn't show because the person didn't know. And at the same time, they even favor people who are omitting information that is unnecessary or redundant, which means children's evaluations of other people as helpful teachers or informants more generally, it's not just about how much you show or what kind of information you show. They're really reasoning about the mental states of the teacher to reason through what is the most helpful evidence that you could have given me and what are you showing with respect to that possibility. Now, what's interesting is that some of the later studies have shown that children are not only evaluating teachers accordingly, but they can also demonstrate that kind of evidence as teachers themselves. So when they are able to omit or not omit information depending on what the learner knows. However, teaching sometimes is not just about teaching what the learner wants to know and providing information that is new. Because it's also about teaching what the learner ought to know by prospectively thinking about what could be rewarding or what might be too hard for the learner to learn. Let me illustrate that with an example. Suppose you were stranded on an island and you tried really, really hard to figure out how to make fire. It took days for you to do that. Now you finally did this and you're exhilarated and you're so happy about that. And that's a really rewarding and important piece of information for you to be surviving. Now you met another person who's also stranded on the island who doesn't know how to do anything. if you had a choice between teaching this person how to pick a fruit versus how to make fire, you would obviously teach that person how to make fire. And that seems very, very obvious, but what is underlining the choice of the choice that you just made? So what makes us prioritizing teaching some things over others? One possibility is the expected utility of information. The hypothesis we're trying to test here is whether children might be able to choose information that benefits other people, that is increasing the rewards, or saves others trouble, that is decreasing the cost. And the question is, are children capable of prioritizing these kinds of information when they are acting as teachers themselves? So to do this, we designed different kinds of toys. So one toy looks like this. This is what we call the low reward, low cost toy, because when you press a button, it makes music. It's very, very easy to discover. So that's why we call it low cost. It makes a sound. It plays music, which is not totally exciting. It's exciting enough. So that's why we call it low reward, low cost. That's one kind of toy we designed. And it was compared to the other one, which we call the high reward, high cost toy. This toy has multiple buttons, and you have to press exactly this and the other button at the same time. And when you press those two buttons, there's a light up globe that spins around, which children find really, really rewarding. So the question is whether children were able to make a choice between these two kinds of toys. This is a collaboration between my former student, Sophie Bridgers, and Julia Hauer-Ettinger, a collaborator at Yale. So here, the choice may be pretty obvious to many of you. Between the top one and the bottom one, who would you choose to, who would teach the top one over the bottom? If you had to choose just one. How about who would choose the bottom one? All right, I see many hands up there. So in this case, it feels very intuitive. The one way to formalize the decision that you are just making is by thinking of these two as a choice between two teaching plans. So one plan is to teach the top one, and the other and let the learner discover the bottom one. The other plan is to teach the bottom one and let the learner discover the top one. And here, if you choose to teach the top toy, the learner would surely learn it and reap the rewards with very little cost, but may have to incur a very high cost to discover how the bottom toy works all on their own. However, if you teach the bottom one, you allow the learner to discover the high reward toy with very little cost because you're teaching them, effectively removing the discovery cost of the learner. And when the learner later gets to play with the top toy all on their own, they should be able to discover it and reap that reward as well. So here, the choices are pretty much overdetermined, but that's not the only condition we had. We had many other conditions to try to look at the relative effect of the cost and the rewards. So another condition contrasted low reward, low cost toy against the low reward, high cost toy. So basically keeping the reward constant and varying the cost. And in the other condition, we had a contrast where we vary the reward while keeping the cost constant. And then the later conditions, we kept the top toy the same, but then increasingly raised the discovery cost of the bottom toy. So what we did is to try to make some quantitative predictions about what children might do when they're choosing between the two toys. And the question was, so let's say you're the child, I'm the experimenter. Well, I have a friend who's going to be playing with these toys all on their own, but I can only teach her one of them. Which toy should I teach her? So this is a decision that children made as a teacher rather than children's own teaching behaviors. But we wanted to ask this question because we wanted to see how children might be taking into account the hypothetical learner's cost and rewards. So this is the model prediction based on the formalizations that I just showed you. And in general, you can see that the model makes a pretty reasonable choice, especially the increasing choice for the lower toy as the discovery cost increases. Now what I'm going to do is to show you the data from actual children. Each bar represents 24 children, and I'll just overlay this on top. As you can see, children's choices were very well aligned with the predictions of the model, suggesting that what children are doing is not just choosing randomly. What they're doing is to think about the cost and the rewards of the two toys and making an appropriate decision. And what we have done, and this is I'm just showing the model predictions on the left and the children's choices on the right. What we have done is to try to see whether all of these components in the model are necessary. So we lesioned parts of the model to generate predictions, which are shown right at the bottom here, and they do not necessarily predict, or they're not as a good fit to the behavioral data as the full model. Additionally, other studies, additional experiments, we have shown that children are not just choosing what they are like, because even from the same contrast of the toys, when we're asking them, hey, which one would you rather play with? They make different choices than what they would do as a teacher. And critically, firsthand experience of the cost is not necessary, because in all of these studies so far, children actually had to discover how the toys work all by themselves, which means for the high cost toys, they really had to try hard for a while to try to figure out how it works. However, when children are not doing that by themselves and they were just told about how the toy works, even in those conditions, children were able to make the appropriate choice, which means they can still actually infer the relative cost of the toy just from how complicated it looks. So what does this mean? Learners can discover only so much, and we know that children are great learners. They can learn actively from their own explorations, but they can only learn so much on their own. It's great to learn from teachers, but teachers cannot teach everything. So we need smart prioritization of what needs to be taught. And this kind of utility-based reasoning can be considered as a basis for curation of useful knowledge over generations. So what I've shown you so far are just briefly some key evidence for the three hypotheses. First, children are learning from others by drawing inferences from data provided by others. They're not just copying or imitating all the time or always trusting others without thinking about it. They're really thinking about who is this person? What does this person know? Is this person providing good data? And they're drawing inferences accordingly. And they also learn about other people too. They're not just following anybody who's old or claiming themselves as teachers. Even when they are learning from teachers, they do think about whether this person was showing good enough evidence or under-informative demonstrations, and they can modulate their learning accordingly. And third, children are not only great learners, but at the same time, great potential teachers too. They're doing more than providing just what is new, but they can think about what the learner knows and modulate their teaching accordingly. Now, all of the studies I showed you so far, and the studies of early reasoning and learning more generally, they involve learning about the external world. However, there's perhaps an even bigger challenge, which is learning about ourselves and learning about other people around us. And perhaps this may be the hardest problem that continues well into adulthood, because we're curious not just about the world, but also about me. Who am I? What am I good at? And what kind of data do we have to learn about these kinds of things? We do succeed and we can do things on our own, and that's useful information. But at the same time, information, perhaps some of the most important information, comes from other people around us. What do you think of me? What do you think of how well I did? Perhaps these are some of the questions that we ask ourselves all the time, and maybe children are asking them too. So what I'll try to do in the time I have left is to try to give you a sense of what we're doing to extend this picture of inferential social learning to learning about the cells and others around us. First, we're incredibly curious to know about us and what others think about ourselves. Children can maybe, perhaps extending this picture, understand that some information from others are more informative than others. And perhaps, just like how they were able to teach another person how a toy works, maybe children might be also able to communicate something about themselves in a way that reflects what is most informative and what is most useful to them. So let's get to the first question. Are children curious? That is, do they do information seeking about what other people think about the self? This is some of the work that's led by Peter Zhu, who's now a second-year PhD student in my lab. And what we were trying to do here is to try to measure children's desire, motivation for self-relevant information. And this is inspired by the marshmallow task. If you have heard about this task, and maybe you'll see what I mean by that in just a second. So this study, children, this is a participant, and the child is asked, hey, do you want to draw a bird or do you want to draw a tree? And they get a choice, and this particular child drew a bird. And Peter takes the drawing when the child is done and puts it in this folder. And let's call this the yellow folder here. And then children are introduced to another child named Jordan. Look, and this Jordan, this child Jordan drew a tree. So this child is shown a picture of Jordan, who is just a child, just like her, about the same age, gender matched peer. And Jordan's drawing goes into this green folder here. And then Peter says this to the participant. Okay, I'm going to take a very good look at these drawings, and I'm going to put a star sticker if I think the drawing is good. And I will not put a star sticker on it if I don't think the drawing is good. And he makes it clear that there's many stickers. So it's not a choice between the child and Jordan about who gets the sticker. Each drawing gets evaluated independently, and there will be a sticker or not a sticker, okay? So he goes to the back of the room, he takes a real good look at the drawings, and then he's like nodding, and then of course it's not clear whether he puts a sticker or not, and anecdotally children are really trying to see what's going on. However, he makes sure that children don't see anything. And then he comes back telling the child, okay, let's take a look at these folders together. So he's just about to come back. He puts one of the folders onto the table, but that's just when he gets a phone call. So he has to run out to do something really quick. And so he leaves the room, leaving the child with either the folder that contains the child drawing or the folder that contains Jordan's drawing. And the question is, well, before telling you what it is, let me just show you the video, just to give you a sense of how this happens. She opens a folder and she peeks at the drawing. And then she waits and waits. We see many different kinds of strategies that children use, and she does it again, because why not? It's easier the second time around. So before I show you the results, you already get a sense of what the study is about, but I can't just resist showing you what happens. So this is the end of the study, and the measure is whether children peak or not. But this is actually what happened when Peter came back for this child.
Yeah. Okay, let's get it.
So she she sounds and acts as if she's surprised, even though she totally knows what is inside. So before I show you the results, let me just emphasize that there was no pressing need for the child to risk peeking while Peter was away, because he promised to return to look inside the folder together. And actually peeking kind of breaks that implicit social norm, even though he didn't explicitly tell children not to peek. However, what we saw, but the question is, do children peek more when the folder contains their own drawing versus another child's drawing? And this is what we have found in the initial study with 20 children in each condition. And currently we're running a replication with a slightly different procedure, not using the sticker because the sticker itself can be rewarding, but we're seeing pretty much the same results in that new version too. Excuse me. So what this means is, children are really curious. They're so curious about what is inside that folder. Of course, they will find that regardless, but information about the self is just that much rewarding that children will risk peeking and they will go out of their way to try to get that information. However, from this kind of result alone, you might say, hey, yo, that's interesting, that's cool, but it's not that surprising either. As caregivers or older cousins and so on, we already know that young children crave positive feedback, right? But I do want to make 2 points here, which is for a long time, we just have assumed that that's the case, that children crave positive feedback. But no study has actually tried to specifically measure the strength of desire. How strongly do children want to know about themselves and compared to what? So we see this study as just one of many other studies that we want to do in the future, just by starting with a simple contrast between me versus another person. Second, from this study alone, you might really think, well, children really do crave positive feedback. There may be sort of praise junkies in a way. However, as I will show you in the next study, children are actually more smarter than that, or perhaps more judicious in their evaluation or evaluations of other people's praises. Because what do we say to our children? Hey, that drawing is just amazing. Just think about the kinds of feedback we give, especially in our culture, to children. Well-deserved, you studied really hard, fantastic job, what a beautiful song. That Lego tower you just made is simply incredible. And we may say to many speakers at conferences too, hey, that was a great talk. And that's all great. It's nice to get positive remarks from other people. But the question is, the meaning of these remarks may differ depending on who it is, why they said so, and what kind of praise or information they gave in the past. So the question is, can children reason about the informativeness of other people's feedback and decide whom to trust? This is a collaboration between Mika Saba, who was a former PhD, and Mike Frank, who's also a colleague in my department. In this study, children were asked to draw 2 tracings. So they made 2 tracings, and each one was put into an opaque envelope, so they couldn't see which one is which. Then children have watched, were introduced to 2 teachers by watching these kinds of videos. And the background was that this is a teacher who was giving feedback to another child's tracing, okay? So there were 3 tracings that were very good and 3 that were not very good.
How about this one? This one doesn't have. How about this one? This is a great thing too.
So then this person gives the sticker.
Let's see. This one doesn't have. Thank you.
So here, it may be a little hard for people to see, but there were 6 tracings, 3 were good, the other 3 were not as good. And we made sure that children were also able to tell the qualities of these tracings too. And this teacher who was introduced as teacher Susan, who is the contingent praise teacher. Of course, we didn't tell children that she was only introduced as teacher Susan. Teacher Susan is the one who contingently praised only 3 of the 6 tracings. I won't show you the video here for the sake of time, but children also saw a video of this teacher Jane, who, when given 6 tracings that another child made, gave a sticker to every single one of them. Again, 3 were good, 3 were not as good, but this person gave stickers to every single one of them, and this is what we call the overpraised teacher. So the question is, we told the children, hey, so remember the tracings that you made earlier? Teacher Jane and teacher Susan are right outside of the room, and they can tell you what they think. So we took the 2 envelopes outside of the room and then came back about 15 or 30 seconds later. And what we told children is, now you can bring back your best tracing to show your teacher. Which one do you want to show? Teacher Susan saw this tracing and she said, this is great. Teacher Jane saw the other tracing and she thought this is great. Again, this was not a choice between the 2 that the teachers made. Independently, 2 teachers looked at each one of the tracings and both of them put the sticker on the envelope. So both of them got praised, but the question is, which one? Whose praise do you endorse? Children were more likely to choose the one that was praised by the contingent praise teacher. However, when they were asked, well, which teacher is nicer, they were more likely to choose the person who actually overpraised. Now, from the first bar, you might be thinking, is it simply because children are just valuing the praise from somebody whose praise was who was a stingy praiser? No, that's not the case, because when both teachers were stingy, but one person contingently praised the good ones and the other person contingently praised the bad ones, children do choose the one, endorse the praise from somebody who previously praised contingently and praised only the good ones. There's another set of studies that are showing related effects too, but the upshot is this. Children are curious about what other people think about what they have done, their performance, or aspects of themselves, but they're not just curious about it. They're actually trying to think about what other people think of them while taking into account who that person is. That is, they distinguish informative and uninformative feedback. They endorse the feedback from more informative people or who were more informative in the past. And some of the new results are showing that children also selectively approach different sources depending on the goal. That is, whether they want to feel good or whether they want to get better or learn. Now, in these cases, children did something and they were genuinely unsure. Maybe some children had some sense, but there were uncertainties about how well they did, and especially what the other person thinks of what they did. However, there are cases where we know something about ourselves really well, but the other person does not know about it, or even has a false belief about what we are like or what we have done. And that's many different kinds of misalignments can happen, but those cases are particularly frustrating, and perhaps you might have a really strong desire to try to correct that person's belief. Hey, you were wrong about me. Let me show you why. So the third study is asking this kind of question: do children actively communicate to revise what other people think of them? So this study is again by Mika Saba, and let me just walk you through what we did. Children were in a room with some toys, and she said, we're going to play with these toys, and Anne, my friend, is going to watch us play. And children are usually okay with Anne coming in. So this Anne walks into the room, and she sits right next to Mika. And she said, oh, wow, look at these cool toys. I don't really know anything about these toys. So she explains and makes explicit the fact that she's ignorant about how these toys work. And I'll just show you a video again to give you a sense of how this unfolded. So Mika demonstrates one of the 2 toys first. So Anne says, oh, that's really cool. She acknowledges the success. The child does the same thing, but it doesn't work. The toy works perfectly fine for Mika. He's looking for the other toy now. So again, Anne acknowledges the fact that the toy is cool, but it doesn't work for the child. So Anne walks out of the room after the child failed twice. And that's when the child succeeds, and you can see the happy expression on his face. So what happened here? This is what we call the absent condition, because the child fails twice on this red toy in the presence of Anne, and critically finally succeeds, but actually Anne leaves right before the child's third time try and success, meaning that Anne leaves the room thinking that the child not make the red toy go. Now, what happens later is there's another toy that Anne has never seen before and Anne doesn't know about, but the exact same experience happens to the child. So the child fails twice and finally succeeds with the screen toy, but Anne is not in the room the entire time. So later we make sure that the child can successfully activate both toys. And then the final question is, well, Anne's going to come back to play with us a little more. Now you can show one of the toys to Anne. Which one do you want to show her? The red one or the green one? Of course, all the colors and everything is counterbalanced, but I'm just using those colors, red and green, to refer to the toy that Anne observed before and did not see at all. So this is one of the two conditions. The other condition, the present condition, was exactly the same as the absent condition, but the key difference is that Anne leaves the room right after the child's success, meaning that she leaves the room thinking that the child can make the red toy go. But again, she hasn't observed anything about the green toy. So I'm going to show you the results. Which toy did they pick? And I want to emphasize that in both conditions, children had strong reasons to actually show the green toy to Anne, because she explicitly said she doesn't know anything about either of these toys. She already saw the red toy a bunch of the times. She even heard Mika explaining how it works. So there's every reason to try to show her the green toy if they are just acting as helpful teachers who are trying to tell Anne about something that she doesn't know about, the world. So Anne did not know how it works, nor has she seen the child interact with it. And this is exactly what they do. They do show a stronger preference for showing the green toy to Anne rather than the red toy. However, in the absent condition, when everything was the same, but the only difference is Anne left the room before the child's success, we see a relatively stronger preference for showing the red toy. And we actually saw the same result again in a larger replication with the exact same paradigm. From this result alone, you might say, well, that's interesting. There is a difference between the two. So it says something about what children are thinking about the situation. However, could it be the case, because the toy choice in the absent conditions are just around chance level, is it the case that children are just simply lost and they're choosing just randomly? However, if just like what we hypothesized in the beginning, there may be two competing pressures that's modulating children's choices. One could be that there's a desire to communicate useful information about the world that is making children choose the unobserved toy. At the same time, there may be another pressure to communicate something about themselves, which is stronger in the absent case. If that's true, if these pressures are competing with one another, and that's why children are at chance, if we can remove the top one, maybe we might be able to see a stronger preference for the red toy. This is exactly what we did in the next study by making Anne say, I know all about these toys. That's what she said when she first walked into the room, which effectively removes any pressure to show something about the green toy or any toy either way. If that's the case, what we should see is a stronger preference for the red toy. And that's exactly what we have found in this study. And what we also showed in a larger replication later is that there may be a developmental change between 3 to 4 years of age. Children were more likely to choose the red toy. In this case, however, we were seeing higher effect sizes in the older kids compared to the younger children. So it's clear that children care about what other people think of them. And when other people have a wrong idea of what they think of them, they try to change that too. And as the last bit, I'm going to show you an ongoing study that tries to show children just don't reason about what this person just saw and what they think of them. What they also do is to generally keep track of who knows what about me. And they are actually able to detect anomalies even in ongoing conversations. So this is Erin Chewy, a fourth-year student in my lab. And imagine this case. If I, let's say, what's your name? What's your name here?
Oh, my name is Perdo.
Perdo, name a friend of yours.
Ruth.
Ruth, okay, great. So if Erin said, I was talking to Ruth and she said, you're really excited about going to CCSC today. There would be nothing surprising too much about that, except that Erin knows your friend. That can happen. However, if Erin says, I was talking to my mom and she said, you're really excited about going to CCSC today. That would be like, wait, what? Because who is Erin's mom to know what you felt about this conference today? So the fact that you might be surprised means that you can generally keep track of who might know something about you and may detect anomalies if something surprising like that happens. So let me just show you a very brief video.
Your mom told me that your favorite food is pizza. Is that true? Yeah. What kind of pizza is your favorite? And you know what, Eddie? I was actually talking to my mom the other day, and my mom told me that her favorite movie is The Nightmare Before Christmas. Do you really like The Nightmare Before Christmas? Yeah. So Eddie, do you remember who told me that your favorite food is pizza? Who told me?
My mom.
Yeah, that's right. And were you surprised that your mom knew that your favorite food is pizza? Or were you not surprised? You're not surprised. Yeah, and do you remember who told you that your favorite movie was The Nightmare Before Christmas?
Yeah.
Yeah, my mom. And were you surprised that my mom knew what your favorite movie was or not? You're surprised. So why are you surprised?
So this child was perfectly able to explain what is going on. Like, who is your mom who knows something about me? Because I don't know your mom. So again, this is very preliminary data. We're just starting to understand this phenomenon better. But currently what we're finding is that children are more surprised when Erin's mom knows their favorite food or movie. Of course, when we run this study on Zoom, we contact the parents earlier beforehand, and we get information about the child so that we can use it in our studies. However, is it because children just simply think that their parent is the one who knows everything? That's not the case. Actually, when the target is Erin's sister, then children are much more surprised that their parent knows something about Erin's sister compared to Erin's mom, which is kind of obvious. Again, this means children's understanding of what others know, and especially what others know about them, as well as other people, are actually pretty reasonable. They don't simply think that their parent knows everything, or other people don't know as much as what they know, or what people know who are close to them, but they are able to keep track of these kinds of things and actually detect anomalies in even very casual conversations. So, trying to step back a little bit, what are these studies showing? Children are curious about what other people think of themselves. Of course, there's a range of qualities that we care about: competence, generosity, many other things. But the important thing is that we care. and we seek feedback from others. We information seek from other people too. And they don't treat all feedback all as equally meaningful. Children are also thinking about who praised or criticized what and why. And they're able to choose information accordingly depending on their goals. However, it also means that inflated praise is meaningless. There are days or times when we just want something positive. And of course, that means a lot too for early bonding and many others as well. However, in certain contexts, especially when children are motivated to choose the best drawing, for instance, they are able to think about the meaning of others' praise and choose accordingly. Children also track other people's knowledge about not just the world, but about themselves too. And they can make strategic decisions about what to communicate. Because in the study that I showed you earlier, these are really seemingly similar data, that is activating a toy or is showing a toy. However, the same act of showing a toy can have very different meanings. It can be to teach somebody about how the world works, or to show, hey, I can do this. And trying to distinguish and isolate these different kinds of motivations has been what's been fun and rewarding about extending this picture further out. And also they stay vigilant about who might know what about them, and they can understand when something implausible happens, or somebody possesses an implausible kind of data. But you might also ask, why do we care about this as scientists? Well, it's a fundamentally human kind of thing where cognition, it's a case of where cognition gives rise to diverse array of self-relevant concerns and desires to learn about the self. Starting with the assumption that we are curious and we are motivated to have other people think well of ourselves, in order to know what to do and what kind of information to provide when, we do need the cognitive capacity to think about other people's mental states and draw inferences accordingly. And that's exactly what these studies are showing. So in a way, inferential social learning is applied inwards rather than outwards to not only learn about the external world, but about ourselves too. And this is precisely the kinds of things that your children might need above and beyond the early bonding between their caregivers as they start to interact with many more people and try to navigate the social, complex social world. It's also a prime example of how we use what we call theory of mind in our everyday lives. Some of you or many of you may be already familiar with this idea of false belief task, scenario that tries to tap into children's ability to reason about other people's minds. And most prior work on theory of mind has focused on how children reason about what other people think about the states of the external physical world. So for instance, this task asks where Sally thinks about where the ball is. However, I might be curious and motivated to think about what Sally thinks about where her ball is, but I'm much more curious about what Sally thinks of me, or maybe what Sally thinks of Anne. So we do use mental state reasoning all the time, not only to think about what other people think about the physical world, but also about the social world, and especially ourselves. And again, extending the broader idea of theory of mind to think about how we reason about these kinds of things has been very fun for me and my lab. And again, the output may look different depending on the culture, depending on how we grew up. For instance, in a typical culture, especially perhaps in the Bay Area, children are incredibly motivated to show other people how they did, and they sort of expect positive social feedback too. And that may not be necessarily true in many other cultures too. For instance, I grew up in South Korea, and things are probably quite different now too. But the amount of positive feedback you got as a child is presumably different from some of you who grew up in other cultures too. However, the underlying motivation and the representational and inferential capacities may be something we all share as humans. We may all have that kind of desire and same ability to think about what other people think, but the manifestation of these abilities may be modulated depending on where we are. And if we were to study this in other cultures, we may not have designed our tasks around the notion of praise, and maybe perhaps could have used some other ways too. Before closing out, I'm just going to give you a brief sense of what we are doing in order to extend this picture further out. I gave you one example today, how we're extending the notion of inferential social learning to learn about ourselves and think about ourselves and what other people think about ourselves. Some of the work is looking at, well, we learn from all kinds of data. Mostly prior studies have focused on instruction from other people by demonstrations and verbal instructions. However, we may also be able to learn from emotional expressions too. And Dr. Lindsay Bowman has also discussed the idea that these kinds of things may matter a lot, especially for early social development. But Yang Wu, who was a postdoc and now a faculty member at U of Toronto, we've been really excited to extend this picture further to think about how young children are using emotional expressions of other people to draw inferences about the world. And also, even though the earlier picture really focused on these teacher-learner interactions, thinking about others' minds to learn about the world and others and ourselves too, it may apply to many other contexts too. So Natalia Velez, who's now starting at Princeton as a faculty member, our former PhD, she's really excited to think about, well, using other people's imperfect knowledge about others to maximize one's own gain rather than learning about the world. So if you're excited to learn more about these things, and if you're especially interested in applying for PhD programs, these are wonderful people to work with, apply to their labs. Also, Erin Chewy in our lab is extending this picture further to think a little bit more about how do we learn from suboptimal channels of information? For instance, when information is compromised by noise, auditory noise, or other kind of unconventional channels. And also more broadly, we're also thinking about how to extend this picture of human to human social learning to think more about how to make machine versus human learning more informative, productive, and safe and beneficial for humans. Actually, I literally just finished writing and submitting this paper late last night, early this morning, depending on how you see it. Excited to share more when I have an opportunity to come back later on. But with that, I will end here. And I don't know how much time I have for questions, but thanks so much for listening and spending your Saturday afternoon with me. It was a great talk. I know you are a very overpraiser, so no, I'm just kidding.
I like questions about the first set of studies by social bridges. When you are talking about the naive utility calculus and you're varying the cost in the stimuli, we're wondering, like, have you thought about varying the reward of the stimuli, and why wasn't there like a similar like variation of the rewardiness when it was related to that? I was wondering, would you like anticipate some sort of like individual differences? What like kind of variables is really favored, and what's the way you think to those the cost?
That's a great question. So the study did vary a high versus low reward, but we didn't do a graded manipulation of the rewards as we did with the cost. And there were a few reasons. First, in the study, the definition of cost was actually a pretty grounded on the truth or the physical aspect of the world, where the expected number of button presses that children had to do in order to discover how it works was our grounding for manipulating the relative cost for discovery. Reward is actually pretty interesting because, of course, if you get 3 apples as opposed to 1, probably the reward is higher, but it may not linearly increase. And it may be very subjective. There are people who don't really like apples, and then 3 apples is not necessarily higher than 1. So what we did in that study to get a sense of which one is high versus which one is low reward was to ask children to empirically ground our definition of high versus low to empirical data from the subjects themselves. It's much harder to do this when it's a little graded. So that's why that's another reason why we didn't do it in this case. However, my sense is that if we have a successful manipulation of the graded reward in an increasing way, we probably would have seen very similar results, again, to a certain extent, because reward is a subjective concept and it may not linearly change. So that's one part of the answer to your question. Individual differences, absolutely. And actually, some of the children who chose the quote unquote wrong choice by choosing the low cost toy as opposed to high cost toy, anecdotally and coincidentally, maybe not a coincidence, those were the two oldest kids in our sample. They chose the low cost toy and said, if I choose this toy, then the learner will learn how these toys work in general, and then we'll have be really excited to have discovered the high cost toy, and they will be gradually learning. So they were kind of referring to this idea of scaffolding that we use in educational contexts quite a lot. And so this individual difference is something about their level of understanding of what teaching means. But again, their choices might also vary depending on, do they prioritize cost over rewards or the other way around? So there's many reasons to think that these are not just a fixed thing. It does vary depending on how you mentally represent other people's costs and rewards. So that's a great question, and thanks. And I think that's